Hi everyone. So in this video we're going to talk about solids, liquids, and gases, which are also called states of matter. So you see these states every single day, but we're going to break down why they behave the way that they do, especially at the particle level. When we talk about states of matter, we're really talking about how particles are arranged and how they move. And so the three main states we're going to focus on are solid, liquid, and gas. And so let's start with this question. Why does a balloon filled with air change shape when you squeeze it, but a balloon filled with water doesn't change as much? Keep that in mind as we go through each state of matter. And so what even is matter? Right? Matter is anything that has mass and takes up space. So that includes solids, liquids, and gases. Even air counts as matter, even though we can't always see it. So out of these three, which one do you think is uh, a solid a representation of what solid matter looks like on a molecular level? I'll take you some time to think about that. Okay. All right. So it's going to be the one to the left. And so solids have a definite shape and a definite volume. That means they keep their shape and they don't change how much space they take up. At the particle level, the particles are vibrating in place. So no particle is ever still. When you look at it close enough, when you look at the molecules close enough, they're actually vibrating. And the state of matter depends on how much movement these molecules are. And so the reason solids have a fixed shape and volume is because the particles are packed and they're very, very close together. You can see here. And so they're locked into position, so the solid keeps its shape unless you apply a lot of force. And so there are two main types of solids. There's crystalline solids, so their particles are arranged in a regular repeating pattern, which is why they melt at a specific temperature. So salt, which is sodium chloride, and sugar are good examples. And then amorphous solids are not arranged in a regular pattern. And so what this means is they can soften over a range of temperatures instead of melting all at once. So think things like plastic, rubber, and glass, they all fall into that category. And then so next up are liquids, right? So when we compare liquids and solids, you can see that the solids are tightly packed together. And then you can see here in the blue spheres, they're a little bit more free, right? They're moving around a little bit more. And so liquids have a definite volume, but an indefinite shape. So that means a liquid keeps the same amount uh, when you put it in a container, but it takes the shape of whatever container it's in. That's because the particles can move around with each other. So imagine, let's say you have a pen, right? A pen stays a pen when uh, when you don't do anything to it. But water, it moves around inside your cup, right? But it's all still water, right? And then your pen, while uh, it is solid, if you heat it up enough, it can turn into a liquid. But that temperature is very, very, very high compared to a liquid, right? And so some of the main characteristics of liquids is that liquids are pretty close together, but they're not stuck in place like solids are, like I stated earlier. So this allows liquid to flow, but not expand to an entire container like gases do. And we'll go over gases in a little bit. And so a main topic or a main characteristic of liquids is that they are attracted to each other due to polarity. So we'll go a little bit more about polarity in a little bit, a few more lectures ahead. But so because of that property, they have this thing called surface tension, right? So because of this polar quality, uh, water molecules are attracted to each other. So this creates what we call surface tension, which is an inward pull between molecules at the surface of a liquid. So inside the liquid, you can see here that the particles are pulled equally in all directions, but at the surface, there's no pull from above. So the net force pulls inward, right? And so there, when you think about the specific water molecules, there's a lot more water molecules packed on the surface because they're only getting pulled in one direction compared to water molecules that are in the center, right? And then you can see here, this insect is called a water strider. So they're really cool insects, and if you're more interested in them, look up water strider. And so what they can do is they're light enough to actually take advantage of that surface tension on the water, so they don't. So they're technically walking on water. Another characteristic of liquids is called viscosity. So viscosity is how much a liquid resists flowing. So liquids like water have low viscosity, so they flow easily, right? Liquids like honey have high viscosity, so they flow more slowly. And then so this is really dependent on particle size, shape, and how strongly the particles attract each other. But to keep it simple, you can see that water molecules are a lot smaller than a lot of the different molecules that are in honey. So smaller molecules have higher viscosity or lower viscosity because there's less resistance to the flowing. So next up are gases. So gases have no definite shape and no definite volume, and the particles are very far apart and move freely. So gases spread out to fill all available space. And so gas particles don't stick together or don't hold a fixed structure. And then so that's why air fills up a room evenly. And then so now we're back to this question, right? Why does an air-filled balloon, why does a balloon filled with air change shape when you squeeze it, but a water-filled balloon doesn't change as much? And so the reason for this uh, is that in a gas-filled balloon, the particles are far apart and easily compressed. So when you squeeze it, the gas moves and the shape changes. In a water-filled balloon, the particles are already close together, so there's very little empty space to compress. That's why the shape doesn't change as much. And so now we're going to talk about the changes of state. What happens when matter gains or loses energy? So here's another question to think about. Why does a cold soda can start to sweat on a hot day, right? And we'll answer this using changes of state. And so, by definition, a change of state is a physical change that involves the transfer of energy, and that energy is usually heat. The substance itself doesn't change, meaning water molecules will still be H2O, right? Two hydrogens, one oxygen. But just how the particles are arranged changes. And so this is kind of a summary of what happens, or what we call the different changes of transition states. And so this is what we call a heat transfer diagram. And so when heat is absorbed, particles move faster and spread out. When heat is released, particles slow down and move closer together. And that's what drives changes between solid, liquid, and gas. And you can see here, when we absorb heat, let's start with a solid. When we absorb heat, it becomes a liquid, and then that means that solid is melting. And then when that liquid absorbs more heat, it becomes a gas. And on the other end, when a gas rejects heat, right, when a gas gets colder, it becomes a liquid. And then when a liquid rejects more heat and gets colder, it becomes a solid, right? And then so let's think of this in terms of how the particles look like with solids, liquids, and gases. Okay. All right, so let's talk a little bit about melting. So melting is a change from a solid to a liquid. At the melting point, particles vibrate so fast that they break free from their fixed position. For water, this happens at 0 degrees Celsius. Right? Freezing, on the other hand, is a change from a liquid to a solid. So as particles lose energy, they slow down and form a regular pattern. For water, the temperature stays at 0 degrees until freezing is complete. And then finally, vaporization is when liquid particles gain enough energy to become gas. Evaporation only happens at the surface, while boiling happens throughout the liquid at the boiling point. And then we have sublimation. So sublimation is when a solid directly turns into a gas without becoming a liquid first. So if you've ever worked with dry ice, for example, so dry ice is the solid form is negative 100.6 degrees Celsius. And so that's why when you use dry ice, the temperature is so drastically different than 100.6 degrees Celsius that it doesn't transition into a liquid state. It goes directly into a gas state. And so we call that sublimation. And then finally, so to answer the question from earlier, we have condensation. So condensation is when gas particles lose energy and become a liquid. That's what's happening when clouds form or when water droplets appear on the outside of a cold drink. And so now we're going to focus a little bit on gas behavior. And so to measure gases, we care about volume, temperature, and pressure. So gas volume is always equal to the volume of its container. Temperature measures particle motion, as we were talking about, and pressure comes from gas particles colliding with container walls. And then I have another question for you. So why does a sealed chip bag look puffed up when you take it on an airplane? So this actually has everything to do with pressure, right? So as the altitude increases, outside air pressure decreases, and the air trapped inside the bag still pushes outward with the same force, so the bag expands. This happens when pressure drops, because when pressure drops, gas volume increases.